Hi, good morning. So I will be talking today in general about the workflow and the analysis of so-called next-generation sequencing data. In reality, I'm going to be focusing what we call now second-generation short-read technology, and how this technology could be enhanced or enabled by cloud computing in some situations. And as an example, I will be obviously referring to the system that we developed in Applied Biosystem, the SOLID system. And one of the things that bring us here is really this breathtaking pace of innovation that has driven sequencing into the forefront again in most areas of molecular biology. And with the introduction of a number of systems, including the SOLID system in 2007, but the 454 earlier than that, of these essentially single molecule cluster technologies that can massively parallel sequence on surface. And what has happened is that the increase in throughput of those machines is faster than the so-called Moore's law from the computer industry, where all of these hardware and computer doubles in a period of time. So now we can start talking about sequencing, for example, hundreds or thousands of human genomes, and the cost of this is reducing dramatically. So in the right-hand side, you can see what was the cost of the human genome in the 90s, right? It was on the order of, perhaps $200 million was what Celera Genomics spent in a single shot to sequence a version of the human genome. And since then, it has been coming down, and we are in the verge of having the ability to sequence a human genome for just a couple $1,000. Today, actually last week, we announced the release of the SOLID System 4, that will be launched in full in the Conference of Advanced in Genomics and Sequencing Technologies in February. But basically, we have now the ability to generate in a single instrument run over 100 gigabases. And by the end of the year, we're going to have an upgrade of the same technology that will allow us to get close up to 300 gigabases, which means that starting in February, March, when these instruments start to roll out in customers, you're going to be able to sequence a human genome for $6,000, and later in the year for $3,000. So what does that mean? Just a few introductory slides about the SOLID system, so you can see what's the magnitude of this in terms of data analysis. There's all of this is based on a scalability of the platforms. In our case, we're using this bit technology that is highly scalable and allows to continue to increase the throughput of the system with minor upgrades into the hardware, so no major instrument switching. And has a flexibility in the ability to multiplex samples. If you don't want to sequence human genome, but just rather sequence exomes, all the exomes in the human genome, you don't require that much sequencing. You can flexibly multiplex the samples in the slide. And since last year, we have also done significant improvements in the analysis and management of the data, but continues to be a challenge mainly because this continues increasing throughput. Right now, one slide of this instrument can generate about 1 billion reads, 1 billion 50-mer reads. So the instrument comes with 2 slides, and so you can imagine that just